verify that f of x and y is equal to natural f of x or y that is equal to a natural log of square root of x squared plus y squared is a solution to the equation f sub x of x and y plus f sub y of x and y equal to 0. This type of questions comes in handy when you're in partial differential equation course, and you have to verify a solution basically. So how do we start? As any verification of a solution, you want to take the you want to plug in the solution into the equation, right? And the equation is asking to take the second derivative of the second partial of the solution with respect to x, take the second partial of the function with respect to y, and plug it into here. So let's calculate those. First, we want to calculate f sub x of x and y. So the outer function is the natural log. So I end up with this 1 over the inside, and then derivative of inside is, and remember we're taking derivative with respect to x. Derivative of inside is that derivative of the square root function. And then derivative of the inside of the square root function. So clean this up, 2 simplifies, and these two multiply together, and so you end up with x over x squared plus y squared. Oh, that simplified nicely. Remember, we could have done this a little bit differently. We could have done, we wrote this one as 1/2 of natural log of x squared plus y squared. So that would have been a little bit less work for us to do, basically. Just a tiny bit less. Now that we're at this point, I want to take another derivative of that with respect to x. Again, y is constant. It would be what is it, low d high. So low derivative of the high with respect to x is just 1 minus high times the low derivative of the bottom. Y is constant, so it's just 2x divided by the low to power 2. And so that's x squared plus y squared minus 2x squared over x squared plus y squared to power 2. That's y squared minus x squared over x squared plus y squared to power 2. So I found one of these two. Let's do the other one. And so I do f sub y of x and y. And this time I'm using this rule. I'm using the equivalent. So it would be 1/2 derivative of natural log with the inside plugged in, then times the derivative of inside. Sorry, 2y with respect to y. And so I get y over x squared plus y squared. And I'm kind of expecting that to happen because there is a symmetry there. And so you can see the symmetry. When it was everything with respect to x and y were symmetric. So I was kind of just hoping that everything would be switching x and y. Switching x and y in the denominator doesn't matter. Switching x and y in the numerator makes it a y. Now, if I take the derivative f y of x and y, again, and I can imagine that it's just switching x and y, so I end up with x squared minus y squared. But if you want to go n over the same denominator as that, but if you want to continue working on it. It's just the quotient rule, and you end up with the same thing. And not necessarily always there is such a nice symmetry, but in this case we had beautiful symmetry. And now I have this, that's that, and I have that, that's that. So add them together. So f sub x, x of x and y plus f sub y, y of x and y is just equal to y squared minus x squared over x squared plus y squared to power 2 plus x squared minus y squared over x squared plus y squared to power 2. Do the common denominator. Everything in the numerator cancels out, and you end up with a 0. So that was verified.